We're going to repeat the thing we did in class earlier on the date that this is recorded. Simply poking the car, timing how long it takes to get from here to wherever it stops, and calculating its acceleration in units of distances, the distance between two dominoes, and a fast count, an 8 count, a 10 count, for example. 1, 2, 3, well, we want to start with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. Or if you prefer, 0 through 10. Now, if you count a second group of 8 or second group of 10, the 8 is actually the 0, or the 10 is actually the 0. You can understand, if you think about it, why we need the 0 at the beginning but not after that. Okay, so I'm simply going to do this, and I'm going to do it pretty quickly so that the video doesn't take a whole lot longer than necessary. I'm working on that whole concept. But here we go. Now you're going to need to count this. I'm going to count to 3 and I'm going to poke it. Ready? 1, 2, 3. Okay. How far did it go? What was your count? Now I'm going to immediately take the car back. In class, I gave you time to estimate the position between these two dominoes. The back of the car was lined up here, and 1 unit of distance would be to this edge of this domino. So you can make your estimate. Okay, we ready? Another one. 1, 2, 3. Okay, you should have your count, estimate your distance. Of course, you can replay the video, so that's no problem. Ready? 1, 2, 3. Okay, now that was 3 trials for the track, for lack of a better word, in that configuration. Now we're going to raise it, put 1 domino underneath it, 1 thin domino, and we're going to repeat. Ready? 1, 2, 3. Okay, I was about to catch it. It almost went off the edge, but that'll work. Ready? 1, 2, 3. Good. Ready? 1, 2, 3. Okay. Now we're going to put another domino underneath the block. And careful the car doesn't roll off the edge. Hot-wheeled cars are pretty sturdy. It might not have been too much of a problem. Okay. Now in class, it was real easy to get this one to roll. Can't hit it very hard. So let's see what we get. We'll try just a light tap. Well, not that light. Okay, ready? 1, 2, 3. Okay. Ready? 1, 2, 3. Good. Ready? 1, 2, 3. I was hoping it would stop before it got to the end, but not quite. Try again. 1, 2, 3. Maybe too hard. Good, it stopped. Okay. Now, we add another domino. And what happens? Well, if we release the car, it'll accelerate down the incline by itself. So let's do that. There might be a little unevenness on the ramp here. It might sometimes prevent the car from starting, but it pretty much goes. Okay, we ready? Now we're going to time it. As a matter of fact, I need the metal strap. Okay, we're going to time it from here to here. So I'm going to, as soon as I release it, I'm going to move down here and put the strap in the way, so the strap will stop it at the stopping point. Ready? 1, 2, 3. Okay, again. And this time we'll go just to the second domino. Ready? 1, 2, 3. And now we'll just go to the first domino. Ready? 1, 2, 3. Now we'll do a couple more on the first domino. Now let's go to the second domino. Ready? 1, 2, 3. The reason I'm doing this is I'm not sure that the car starts exactly the same each time. We want to see what kind of consistency we can detect. Ready? 1, 2, 3. Now notice that when the car was stopped at the second domino, it didn't travel 2 complete distances, okay, 2 complete units of distance. The back of the car was lined up with this edge of the domino, okay, the back edge of the domino, if we think in terms of the direction of motion. And here the front of the car was lined up with the back edge of the domino. So you're going to have to, in estimating your distances, you're going to have to take the length of the car into account. Now, it might be profitable to just measure how many car lengths constitute one of these distance units, and it looks like for this car the distance unit turns out to be pretty much close to 3 times the length of the car, and that should help with some of your estimates.